All right, so we have a huge announcement here from DeepSeek, and we have covered some of their models before. So they are announcing DeepSeek R1 Lite Preview, which is now live, and they are claiming this unleashes supercharged reasoning powers. So we have done a couple of videos already on reasoning LLMs, and that this is really the future. And going into 2025, this is where a lot of the focus and investment is going to be. And they're claiming O1 preview level performance on these two benchmarks and transparent thought process in real time. So this is really nice because with the O1 models from OpenAI, we don't get the thought process. Now we get the raw thought process, which is something that I spoke about before and is going to really help to understand how these models are doing the reasoning part and potentially even improve the way we interact and prompt these models. Open source models and APIs coming soon, so that's really exciting. The API availability will be something I'm interested in and probably will do a video when this is made available. And you can chat with it here. I'm going to show you a few examples of a few tests that I've done. And overall, these are the results. So if you look at it, the math benchmark in particular and this one, their model does extremely well compared to the previous models like O1 Preview. And I'm not sure what to think about these results. It's really hard to tell when there are not like a lot of examples. Benchmarks really don't tell much as far as I can tell with these reasoning LLMs. It's really about testing really hard prompts and things like that, which is what I will show in a bit. And then there are other benchmarks which they don't perform as well compared to the other competitive model, which is O1 Preview here. So I'm going to do the first test here. You need to enable this. You get 50 messages total. I have 41 messages left because I've been doing a few tests. So I'm going to enter the first test here. This one, I've tried this with many of the latest models, and they really struggle with this because maybe of how I present the information, they cannot really make sense out of the information and even what I'm asking for. So there's a lot of confusion with the standard LLMs. Now with the reasoning LLMs, these ones that can do thinking steps, can generate thinking steps. I'm very interested to see how DeepSeek performs. So I'm going to test this out. Now, it's already doing the thinking. You can see there, this is very similar to the O1 model. I expect that this becomes a sort of standard interface for these models. And so we're going to see this a lot via APIs. Now, this is a process that takes a little bit of time. So always keep that in mind when you're using these models. There's some expectation that you will wait a few seconds, sometimes even minutes for some of the tasks. So this one took 19 seconds trying to figure out what the problem is. And then it says our task is to determine which of these 5 candles was the first one. And then it tries to understand that problem. It says, now, since all the candles were burning for the same amount of time until each one was blown out, the candle that was blown out first would have been burning the longest before being extinguished. Therefore, this candle will have burned down the most, meaning it has the least length remaining. That's correct. And this is something you don't see with the standard language models. This step-by-step really does help the model figure out how to solve this problem. Now let's look at the results more at the bottom. There's more things that it's trying to figure out. That's really interesting. I won't go through all the different steps, but you can see that it says, so the answer should be candle 4, which is the correct answer. But you see how much it had to actually think about in terms of this problem to actually come up with one answer. And there are problems like this that may look easy and some even harder problems that the model needs to just break things down, right? And this is one of those problems. And so this is a very suitable problem for these type of models. There might be other math puzzles and math type of problems that you want to try out. So you can definitely test this model because I think it does have a lot of potential from what I can see. I've tried another test here. So this one is, what are the last 4 digits of the sum of the first 70 prime numbers? Again, the standard language models really struggle with this. And I tested the model without this feature. Okay, so this one just goes through the standard language model that they have available, and it outputs this, which is the wrong result. For some reason here, it got confused, and the correct result is actually this. It actually got the result, which is really remarkable, but somehow it got confused. And again, very standard to see on harder problems like this. And so what I'm going to do is I'm going to go back to trying this same problem here with their DeepThink model. So let me go and try a new chat. And this one might take a little bit longer. I'm just going to run it. So I'm going to leave this running and I will show you because I already did this once. It takes a bit more time for this one. This is the first one when I tried this particular problem. You can see it here and I enabled DeepThink. And I found something really interesting here. It's explaining what the problem is trying to understand, but this is something that I haven't seen with any of the models before. So it says these are the first 10 primes and then it goes through that. Then it creates a sum of that. Then it says the next 10 primes and then it goes through the next 10 primes and then add to the previous sum. And you can see that it goes through that. And then it finally arrives to the final answer. And then in the end, it says, okay, So wait, that seems like more than 70 primes. Let me count them properly. It made a mistake and it corrects itself. And then it says, okay, assuming I have the correct list of up to the 70th prime, I can start summing them up. And then it uses modulo here. And you can see right here at the bottom that it fixes the mistake, which is really impressive, I think. And then it says, so the sum of the first 70 primes is 10,887, which is the correct result for this. Then it says, no, to find the last 4 digits, it says the last 4 digits are this. And then again, it goes through some calculation again, right? And in the end, it says, therefore, the last 4 digits of the sum, first 70 prime numbers are 0887, which is the correct answer here. So you can see now it summarizes the steps and it doesn't make the mistake that we saw in the previous generation where it wasn't using this feature. That's pretty impressive. I think this is a good result. Now, we tried 2 math questions already. Now, let's try something different and see how robust and good this model actually is at something like coding, for instance, or even like crossword puzzles. First one I want to try out here is a bash script. Now, I took this exact same prompt, which is available in the blog post that OpenAI released when they released their O1 models. So you can find that there, but I'm going to paste it here and then I'm going to try it. So this one should write a batch script that takes a matrix represented by this string format and then prints the transpose in that same format. So it's going to go through those steps. Now, it did it really fast, like in 5 seconds, which is nice. Now, this also doesn't work really well with the standard LLMs. So I'm very curious to see how it did this time using this model. I'm going to test this in my terminal now. So I'm going to copy this code. Then it gives me some steps on how I should use it. And it tells me what is the expected output. So by the way, this is the correct output for this particular example. So I'm going to go and test it now. All right, so I'm going to start from scratch here. I'm going to do nano. It's much easier to use. I'm going to say deep transpose at sh. And here I'm going to paste the code. All right, so that's the code right there. I'm going to exit this. Okay, that looks good. And now I will need to change this. So I was doing some other tests here. Yeah, in order for me to have permissions to run this, I need to change permissions here. So this should work. Okay, that works. And now I should be able to run this. Okay, I'm just going to change the name here. All right, so that's the input is the same as was used in the example. So I'm just going to run this. And you can see that this fails. This is not the correct output. The expected output is something different. So it totally fails for this one. Now, I actually tried the same on the O1 preview model. And I have the example here and I will run it for you. I believe it's going to be this one. And you can see that this one outputs the correct one. So this is the comparison here with the O1 preview model. So the O1 preview model is really good at this particular task. And you can find, again, the example in the main announcement that OpenAI did with their reasoning LLMs. But this one, unfortunately, it doesn't work well. So it needs a little bit more work. The way how you would try to improve this is you go to the actual thinking steps and try to see where it went wrong. Because it did this really fast, but it probably didn't do enough. And maybe you can prompt it to look at the steps more closely, which is not something you want to do and it's not efficient, but I can see that it made a mistake here and it needs a little bit more work. All right, so yeah, see the expected output here. This is the correct thing, but it outputted something completely different. I'm going to try one more interesting test here. And I think this is probably the hardest out of all of them. This is a crossword puzzle, and I took inspiration from a recent blog by Ethan Mollick. Ethan Mollick writes a lot of really cool stuff and his perspectives on some of these new developments. And he actually wrote a test that I have been testing on with some of these newer models, especially models that do reasoning. And I actually rewrote the prompt, and I think I got it exactly how he wrote it here. And this one is about solving a piece of a puzzle here, a crossword puzzle. And he realized in his own experiments that, it wasn't enough. Even this model that do reasoning made a lot of mistakes to solve this. And the mistake, from what I can understand, what he wrote here is that the model made one simple mistake and then it threw off the entire solution. And what he did was he actually decided to give the model a clue. And this is the O1 model, by the way. And it told the model one down is apps. So it gave one of the answers, solving the puzzle. And then after doing that, it was able to completely solve the problem. Now, I've actually tested this problem on the O1 model when it was released, the O1 preview model specifically, and I was able to reproduce this. Now, if you go and try the same prompt on the O1 preview or O1 mini even, it's not able to solve this problem for some reason. I don't know if they changed those models. I'm not able to reproduce it. But I was interested to test the same crossword puzzle on this particular model that was released by DeepSeek, since it's along the same type of capabilities which they are trying to incorporate into these newer models. So I have the exact puzzle here. So this is the across information about the across, right? The 4 spaces, how much spaces it takes. And then here is down, and you can see here, these are the spaces. This is a really good test. I don't have any expectations that DeepSeek will be able to solve this. And in fact, that is the case. And when I looked at the actual thinking steps, it really got confused. It was making a lot of mistakes. It got stuck in some cases, and it produced a lot of information here, right? It says, for instance, I'm really stuck here, and maybe I need to consider what I've got the wrong answer for one of the earlier clues, which is causing a chain reaction of errors. So it makes those mistakes and it's not able to correct itself. From my observation, I do think that for tasks such as this one, that require more knowledge of the real world, I think these models are going to struggle a lot. And potentially, maybe incorporating this in an agentic workflow could work a lot better. Like if you give it a search engine, for instance, it's able to call the search engine, pull information, pull more recent references, because it doesn't do so well with recent references. And in fact, when it makes those mistakes, it's usually about a new concept or a new reference that people are using, and it struggles with that. So anything that's newer knowledge or newer events is going to make a lot of mistakes about that. And so this is something I'm noticing with these reasoning models. So be very careful when you're using them, for instance, in an agentic setting. Don't expect that these models can solve some of these problems. Pay very close attention, especially again for knowledge intensive problems like this one, for instance, that it needs to know more than just basic knowledge. It needs to understand references, like modern references. And so it really struggled with that. This is why I'm using this test, and I will continue to use this test until I see that these models can get this problem solved consistently. I actually gave it a clue, and I noticed that, again, it took 78 seconds. That's not efficient because it almost took as much as the initial iteration. And again, it wasn't able to solve it, even giving it the clue. But I did not have any expectation that this would be solved. Similarly, if you try this on O1 Preview, it will not solve this problem. It has the same issue. I'll be developing more code-related problems like this that require more recent and more deeper knowledge of the world and events and so on. And I will also be testing out things like math puzzles, things like that. So I'm developing a reasoning benchmark at the moment, and this is something that I'll be sharing here in my YouTube channel. And I'm also working on some courses along these lines. I don't have much to share right now, but when the time comes, I'll be sharing more information about that. I'm excited to announce that we added 2 new courses recently in our academy. So we have Introduction to AI Agents and Introduction to RAG. So RAG was released yesterday, and this is probably the most comprehensive introduction to RAG that you will see today. And basically what I did with this course is try to share as much as I could in an introduction course. I have an advanced course that's also coming, but this course is packed with a lot of information. It goes through the architecture. I talk about chunking, I talk about embedding models, semantic search, retriever, and different enhancements that you can incorporate. Something that I really did different in this course was, how do you incorporate things like chain of thought into the RAG system to improve the generator? How do you improve the RAG system using tool calling? And another hot topic right now is agentic RAG. I made an introduction to that. I also built a system using agentic RAG. We also introduced what is function calling. This is one of the courses that I'm most proud of. And again, if you're interested in learning about this, I would encourage you to check out the link below. And right now we have a Black Friday deal. Something else that we do also for our courses is that we have a community. So as part of the academy, you get access to a community. You can interact with me directly. I can answer questions there. I'm enjoying that because there's a lot of really cool ideas from the community, and I get to spend some time thinking deeply about some of the types of applications that people are building. That's another advantage that you get with this particular academy if you join it. That's it for this video. Consider leaving a like and subscribe to the channel if you haven't, and I'll see you all on the next one.